Alright, so I'm trying to transfer the slide to the device. Let's see, because the device already out of battery, so it will take some time. Let's see what happened here. So it's a Google Drive. The pen is have battery. Sorry. So the device not enough battery, so I cannot use that. I have a device actually a tablet. However, is a Huawei. The Huawei is not compatible with the Google Meet for teaching, so that's why I cannot use that. Alright, so I think we just need to proceed lah with this method. So I need to share my entire screen. Share. Right. Okay. So let's say if you answer something, if possible, can you use your mic because I cannot read your message in the chat. Okay. So we proceed again. So now we already done here. We already done for the number one and number two. So now we need to calculate the zeta and omega m, the damping ratio and the damping frequency. So how you need to calculate it? So based on the percentage overshoot information, or based on the settling time information, or based on the peak time information. Right. So what need to do? So we just go to the question again. All right. So this is step number one. This is step number one, and this is step number two. So we go to the step number three. To duplicate this one. Okay. Just open it. So I just need to delete everything here. Delete everything here. Okay. So let's say the question asks you. The question asks you. I just need to insert a text box here. Design a pole placement controller to make sure the compensated system have 20% overshoot and 5-second setting time. Okay, so this is the additional question. Okay, that's a okay. All right. Okay, so your task is you need to calculate the zeta and omega m, the damping ratio and the damping frequency. So based on this information, you can calculate damping ratio and damping frequency. So what is the formula that you need to use? If you still remember during control one, okay, how there is a this formula. To calculate the damping ratio, you need to use this formula. Negative ln percentage overshoot divided by 100 divided by square root of pi square plus ln square percentage overshoot divided by 100. Okay. So in order to calculate the zeta omega n, you must know this formula. Okay. And then after that, you must know the settling time formula. This is the settling time formula, 4 divided by zeta omega n. Somehow or sometime the question give you the peak time formula. So you must know the peak time formula too. This is the formula for the peak time. So in order for you to calculate the zeta and omega n, you must know these three formula. Okay. You know these three formula, you can calculate the zeta and omega n. So now we have the information of the positive overshoot and setting time. So we just need to use this formula and the setting time formula. So we not need to use this one, no need for this question. So what we need to do, just plug in all the information here to this formula. Okay, so firstly, please calculate the damping ratio. What is the damping ratio value? You can use your calculator. I will also calculate the value and see what is the result. 20 bagi 100 loan answer bagi dengan 3 cos 2 tambah answer cos 2. So what is the answer? If you plug in 20% to this formula, negative loan, negative loan, negative loan, the this one positive overshoot divided by 100. I try to look at the comment. What is the answer in the comment? Maybe some of you put the answer in the comment. Not yet. Maybe I can try to. To log in Google Meet. Where is my Google Meet? Okay, go to the PSDC. Call message. What is the answer? Okay, I would use my mobile phone to see the answer. Yep, that's correct. 0.456. So you just could put it as the 0.456, 0.456. Now, you need to calculate the omega n. By using this formula, you know that the setting time is 5. So 4 divided by 0.456 multiply with the omega n. Now you can get your omega n equal to, I also would calculate 0.456 multiply with 5 or divide by answer. What is the answer again for the omega n? You almost finished to design the pole placement. It's very simple to design the pole placement controller. Okay, according to this, what is the answer? Am I share my screen? Yes, I'm sharing my screen. Am I mute my voice? No. Okay, that's correct. 1.75. So now we just put the pointer. The answer is 1.75. 1.75. All right. So done. Done for the step. So we go up again. Okay, easy. So you already complete the first step here. First, second, third. So now we go to the fourth step. Step number 4. Okay. So you have the damping ratio and omega n value. You just need to substitute to this equation formula. Okay. So we just proceed. So now we go to step number 4. You need to replace all the value to this s square plus 2 zeta omega n s plus with omega n square equal to 0. So you just substitute everything the value there, s square plus with 2, theta is 0.456 multiplied with the omega n 1.75 s plus with 1.75 square. So this is the answer will be s square. What will be the answer for the first one? 1.75 multiplied with the 0.456 multiplied with 2. Okay, what is the answer? 1.596s plus with 1.75 square will be what is the answer? 1.75 square. Oh, okay. 3.1, 3.0625. Yep. 0625. Then step number 4. Easy. Okay. So now done. I try to duplicate again this slide. Okay, to make sure you are continue this thing. Delete. It's good to have you to join me calculate all the values. Thank you so much. So this one, I just put it away. Okay. So I know that according to the steps that we have before, we obtained before, pointer option, sorry, pen, we have two information there. S square plus 1.596 S plus with 3.0625 equal to 0 when we calculate at the right hand side. And then when we calculate the left hand side before, if you still remember, we get this value. We get this value 540. Okay. So I try to copy this value to the previous slide. 540. Okay, all right. Okay, so now we have the value on the left hand side, we have the value on the right hand side. So the step asks you to do the compare. Then compare the characteristic equation. Then compare the characteristic equation. So we need to compare the equation left and right together. And then after that, we can finally calculate the k values. Okay, so now we are at the stage to compare. We are at the stage to compare. So what do you think? At the left hand side, we have s power of 3. At the right hand side, we have s power of 2. Do you think we can compare it? Because they have different order of the system. What do you think? We can compare or not can compare? I know the answer will be easy, but I still want to listen the answer from you as because I just want to make sure you follow whatever happens here. Okay, if you can answer this quickly, we can finish the class as soon as possible. Yes or no, we can compare. At the left hand side, we have s power of 3. At the right hand side, we have s power of 2. Is it we can compare these two equations, characteristic equations?
Cannot.
Cannot. Yes, we cannot compare. We just can compare if the both of the characteristic equation have the same order. This is third order, this is second order. We cannot compare. So what we need to do, we need to make the second order system become third order system. We need to make it like that. Okay, how we want to make it to change from the second to third, how we need to do it. Okay, so example, according to the, let's say, this thing will give you post location. Example, something like this. This is example of the post location. Okay, this thing actually represent, if we try to simulate this characteristic equation, okay, what is the output that we can get is, we can get the output of the system something like this. We have 20% overshoot, 20% overshoot, and the setting time about 5 seconds. This is the thing that we get. If we try to simulate it using the MATLAB, because we can get this graph. Why we get this graph? Because based on the value that we calculate before, we need to have 20% overshoot and 5 seconds at a time. So now, this is the system, original system. We want this original system become like this. Become like this. So that's why we need to calculate the k value. What is the suitable k value in order to make sure this characteristic equation become like this characteristic equation. Okay, all right. I'll give you one more thing. So now, if you want to make sure the second order system become the third order system, we need to add another pole. We need to add another pole. So now, this is the pole that we can get. We can add whatever according to our design. What according to whatever you want lah. So I just duplicate it here. Okay. Pointer option. Then. Okay. So now, if we add the poles here, your design criteria will not get 20% overshoot and 5-second setting time anymore. Because when you add another pole, this thing will be changed and this thing will be changed. It will be affected. This pole will affect the performance of this 20% overshoot and 5 seconds setting time. Okay. However, you can choose, in order to minimize the effect, to minimize the effect of the third pole, so you can place the third pole 10 times far away. So this is, let's say, this is -1, this is J2, and this is -J2. Okay. So you can place the third pole here 10 times far away from the dislocation of these two poles. So example, this is -1. So what is the location of the third pole here? What do you think? This is -1, right? So in order to minimize the effect of the third pole, because we want to maintain 20% overshoot and 5-second setting time, but when we add another pole, the third pole here, it will affect. You will not get 20% overshoot and 5 seconds at the time. However, we can minimize the effect. Maybe from 20% overshoot, it will become maybe about 21% only. The setting time will be about 5.2 second change. So it means that we minimize the effect of the third pole. So the rules to minimize the effect, we need to add the third pole at least 10 times far away from the dominant poles. Okay, so I try to draw it again. This thing, right? So pointer option, pen. Example, we go to straight away to the question lah. This is s square plus with 1.569. 1.569s plus with 3.025. 3.0625 equal to 0. Almost there. If we can finish early, so if we can solve the answer quickly, so we can end the class. So equation, try to calculate the poles here. 1.596 3.0625. So you get the pole at the S plus 0.798 plus minus J 1.557. You factorize, you factorize these two, you can get this is the post location. So it means that this is the post location here. Negative 0.798. And then this will become J 1.557. And this is negative J 1.557. Okay, because this thing is S cubed plus with K3 plus 4, I think. 4, 5, sorry. 5S plus with K2 plus 4S plus with K1 equal to 0. So we need to add another pole here in order to make sure it become S power of 3. Okay, so the rules is you need to choose the third pole must be 10 times far away. Far away. So based on this value, what is the third pole value that you need to put? Negative. What's the value there? According to this value, 10 times far away. So you mean that you need to
Negative 0. Negative 7.98.
yes, that's correct. However, if you try to multiply with a negative 0.798, will be easy or difficult? You have this thing, so you need to multiply with the negative 7.98. It will be easy or difficult?
Bit clumsy.
Okay. However, you can run up this number. What is the best run up number you can put?
Negative 8.
Yeah, you can choose -8. Okay, it won't be any problem. So just make yourself easy to calculate the values. Okay. So now you have this thing. You have s square. Almost there. Almost there. Almost finished. S square. Difficult to write down with this mouse. 596 s. The six not look like six. Plus 3.0625 and just multiply with the s plus with 8 equal to 0. And then you just solve everything here. What the answer will be, I just straight away put it the answer x square plus with 1.596 s square. So terrible. 1.596 multiply with the 8, you will get 768, sorry, s plus with 3.0625 s plus with 3.0625 multiplied with the 8, you can get 24.5 equal to 0. So at the end, I have to put the text box here, put it here. At the end, you get your insert where is the insert equation? Is there an equation here I can put? Home. It's not equation. Tak apalah. I just put it here. The answer be s power of 3 plus with 9.59 s power of 2. Is it? Plus with 12.768 plus with 3.0625 become 15.8305 s plus with 24.5 become 0 equal to 0. So now you have this equation and then you can compare to this equation. Maybe I can rewrite again. Plus with a3 plus 5 a3 plus 5 s power of 2 plus with K2 plus 4S plus with K1 equal to 0. So now, can you calculate what is your K1, K2, and K3 values from here? So can you help me to calculate the K1, K2, and K3 value? So what you need to do, you need to compare this is s power of 2 and this is power of 2. This is s power of 1 and this is s power of 1, and this is without s is mean the s power of 0, and this is s power of 0. So you can calculate the value lah. K3 plus 5 equal to 9.59. K2 plus 4 equal to this one, and K1 equal to this one. Okay, I believe it should not be negative value. It will be positive value, I think. Is it correct, Jetly? Positive or negative value?
I don't know. That's why I need to confirm.
Okay, so you just compare you just compare K1 here. I need to use a pen lah, better. K1, positive K1 equal to positive 24.5. So you can put it K1, positive K1 equal to positive 24.5. So it means that the K1 equal to 24.5. K2 here will become, yep, that's correct, 11.8305. And the K3 here will become 4.59. So this is how you design the pole placement controller to the system. Finish. So what you need to remember only this table. The step 1, 2. The step is number 1, number 2, number 3, number 4, and then compare. If not comparable, so it means that this one as power of 3 and this is as power of 2, you need to add another pole, which is the root 10 times far away, and after that finally you can calculate the k values. Done. All right, so normally after that we have this thing, you have everything here, so we need to draw the signal flow graph lah. So how we can draw the signal? Why we need signal flow graph? Because after the final slide of the signal flow graph, you need to do lab number 2. Your lab number 2 is a pole placement controller design. So I will upload the lab module on tomorrow. Okay, on tomorrow. And then you need to do the lab lah. So on this coming Monday, I will go to Penang. I will go to Penang. I will proceed with the next topic for the control engineering 2. And then after I covered some of the topics, then we will do lab number 2. So we will do discussion there in order for you to complete lab number 2. So on next Monday, you will do two things. First is the next topic that we need to cover in control. And the second thing, we will cover how to solve for the lab number 2. All right. So I will give you more advice, more order or direction during the WhatsApp group. Okay, so now we need to convert to the signal for graph. Duplicate again. Okay, so I just need to delete everything here. No, delete this one. Okay, the signal for graph. Oh, I will also will give your answer script for your test, and I'll give you the result, your result, your test results. All right. So now, how we want to do that? So this is the original system. So we just need to convert everything here to the signal flow graph. Signal flow graph. So because this is third order system, you will have three integrators. Third order system, you will have three integrators. Remember, because every integrator will represent one, two, three, one, two, three. Okay, and then after that, you must know that you must have starting from input and end with the output. Okay, done. Okay, and then after that, you just rename your label. It must be starting from x1. This one x1 dot, because if you have x1 dot, if you integrate x1 dot, you have x1 dot, you integrate x1 dot, it will become x1. You come here. Okay, after that, this will be always become x2, and this will be x2 dot. This will become x3, and this is x3 dot. Okay, easy. All right. So now you know that x1, x1 dot, x1, x1 dot, x2, x2 dot, x3, x3 dot. Okay, so now we go to one by one. So the equation is, this is represent x1 dot, x2 dot, and x3 dot. What is the equation of x1 dot here? This is x1, this is x2, this is x3, right? So it means that x1 dot it actually equal to 0 multiplied with the x1, 0. 1 multiplied with the x2 will be x2. 0 multiplied with the x3 will become 0. Plus with 0 multiplied with the ut will become 0. So you get that x1 dot equal to x2. So you can put it here 1. So now you can get x1 dot equal to x2. Okay. So we go to the second equation. I believe from this one you can get x2 dot equal to x3. If you try to write down the equation here, x2 dot, run all the multiplication, you will get x2 dot equal to x3. 1. So now you can get the x2 dot here be equal to x3. All right. However, you can see the x3 dot here is quite complicated. So if we write down the equation of the x3 dot here, you can get negative 4 x2, negative 4 x2, and then plus with negative 5 x3, so minus 5 x3, and plus with 1 multiplied with u, you got u. So you can get that this is your x3 dot location must be negative 4 multiplied with the x2. So this is your x2. So negative 4 x2. And then negative 5 multiplied with the x3, this is your location of the x3. Sorry, this is location of your x3. So must be negative 5 x3. Okay. And after that, plus with u. It means that 1 multiplied with the u. So this is your original system, signal flow graph. But we have not complete for the output equation yet. For the output equation, you can obtain that the output equation is y equal to 100 x1 plus with 20 x2. So this is your y location here, and this is your x1. So the first gate is 100 multiplied by x1, and this is your x2. The gain will be multiply 20 x2. So this is your original system signal flow graph. So as I mentioned before, according to the signal flow graph for this thing, you just need to get the feedback only, feedback, feedback, feedback. You just need to add another point here. This is your x3 dot. This is your x3 equal to x2 dot. Right. So you can see that this is your new u. Okay. So you need to if you refer here x1, it will become refer to negative k1. If this x2, the feedback will be negative k2. If x3, the feedback will be negative k3. So what you need to do, you look at your signal flow graph again. Where is the signal flow graph? All right. So this is the point that you need to put it here. You can see this is your x1. So the feedback will be negative k1. So according to your answer, the k1 is, what is the k1 value?
24.5.
24.5. You just need to negative the value, negative the whatever value you get. And then from the x2, the feedback will be negative k2. So the k2 value is negative 11.8305. Okay, and finally, from the x3, the feedback will be negative k3. What is the k3 answer? Last one. After that, finish for the purpose
Negative 4.596.
negative 4.596. Actually, I can see the answer from the chat box, but I just want to see the response only. All right. So now, previously, you already put the signal flow graph for the original system. After that, you add the K gain value, and this is the pole placement controller. Done. Finish. Okay. So after that, we just need to add another one thing. This is gain 1, and this is the R. So finish. Done. You design the pole placement controller to the system. Okay. So the key point for you to answer your final exam, and also in order for you to do your lab number 2, for the question of pole placement controller, what you need to do, you just need to remember this step. This step is really important. And then before you implement this step to design the pole placement, you need to check these two criteria. The system must be in phase variable form, and the system must be controllable. After that, done, complete. you can do your final exam for the post placement controller design and also for the lab number 2. All right, so I will upload this slide to the e-learning and also the recorded video for this class to the e-learning also, to the YouTube and e-learning. Okay, so let's say if you don't have any question regarding to this topic, it means that the class is end, finished, and see you on this coming Monday in Penang. All right. So if you have any question, so I will wait another 5 minutes to see your question. All right. If not, that's all. Next Monday will be at 10 a.m., 10 in the morning. All right. All right. So thank you so much for your response and attention.
Okay, sir.